Hello, it's Dr. Daystorms again, and today we're going to be discussing the mole, and how to use the mole, and exactly what is a mole. So perhaps, let's see if we can first catch a mole.
Well, I'm back here again. I missed another mole, and it doesn't happen too often where I actually see the mole and miss it. The last time I was pulling the mole by the tail, and this last time here, I actually had my hand around the mole's body, but he got away. So I am here early, and I'm going to nail him. Cold weather's coming in, so I need to get him. Yes! Oh, yes! Oh my gosh. Oh, this is the guy I missed yesterday. I nailed him.
Now, why on earth anyone would want to do that who's in their right mind, I have no idea. But that's not the kind of mole that we're talking about. No, what we're going to be talking about is the fact that when we are discussing things on the atomic level, these are very, very small molecules. So, for example, how many molecules are in a liter of water? It would be literally 10 to the, tens of powers, if not hundreds of powers. So just like a dozen is equal to 12, so you can have a dozen eggs, or you can have a baker's dozen, which is equal to 13, or we can talk about like a century being 100 years. The mole is just a number, and technically it's called Avogadro's number, but it's equal to 1 times, it's equal to 6.022 times 10 to the 23. So it's this huge number. I think sometimes people get scared whenever they hear about it because it's something that's new or something that's different. Okay, so we're talking about the moles, and once again, this is just Avogadro's number. 6.02 or 6.022 times 10 to the 23rd. And what it does is this allows us to talk about very, very tiny molecules, but use it in a manner of speaking. Like, it'd be difficult for me to tell you, there's no way for you to go out and measure 2 molecules of water to react with, or 4 molecules of carbon. No, you're going to measure like grams, and there are going to be several, a large order of magnitude number of water molecules or carbon molecules or copper molecules or what have you. And so it just helps us to have some unit of measurement in order to put this into numbers that we can use. And so instead of saying a dozen or 100, we say a mole. And once again, a mole is equal to 6.022 times 10 to the 23rd. 1 mole of carbon 12, so the isotope carbon 12 has a mass of 12 grams. And this is really, really helpful. So by definition, the mass of 1 mole of any substance is actually equal to its atomic mass. So it is possible to actually go out and measure a mole of water, or a mole of salt, or a mole of copper. Okay? So the molar mass is just the mass number for that element. So, for example, we say that, let's take oxygen as an example. Remember, molecular oxygen is O2, because it's a diatomic molecule, so it's 2 times 16.00 ATMs. So it's roughly equal to 32.0 ATMs. Well, 1 ATM is equal to 1 gram per mole. So that literally means if we want to measure out a mole of oxygen, you just have to measure out 32 grams worth of oxygen gas. Okay, so the formula weight or molecular weight in AMUs is the same number as the molar mass, which is grams per mole. So this provides a way for us to go from grams to moles, or back and forth, and then we can actually find out the exact number of particles. That's really cool. So for example, if we just look at silver in this example, elemental silver, silver metal, it has an AMU's, its formula weight is 107.9. So that means its molar mass in grams per mole is 107.9. So therefore, if you measure out 107.9 grams of silver, you have exactly 1 mole of silver molecules. Okay? And that contains Avogadro's number of those particles. So that literally means, here's just a picture I've taken from the web, where it's showing a mole's worth of copper, a mole's worth of sodium chloride or table salt, and a mole's worth of water molecules. So let's just figure out something here and use an example. Let's find out how many particles, or how many molecules, if you want to think of it that way, of magnesium sulfate are in 100 grams of magnesium sulfate. So, what do we need to know in order to do this? You need to know the formula weight. Okay? We also need to know the number of, or you have to know what Avogadro's number is, which they like to give that the capital N. And we're already given the mass, 100 grams. Okay, so let's go to our handy dandy periodic table. The molecular weight of magnesium can be found right here. And that is 24.31 grams. Sulfur is 32.06. So that's magnesium. Sulfur is 32.6. And each oxygen is 16. So since there's 4, it's 4 times 16. And we just need to add these up. Let me erase this out of the way. Okay, so let's use our calculators here. 24.31 plus 32.06 plus 4 times 16. That gives us 120.37 ATMs of magnesium sulfate. I'm sorry. That's the formula weight. Okay. which that's also equal to 120.37 grams per mole of magnesium sulfate. So the question was, how many particles, or how many molecules, of magnesium sulfate are there in 100 grams? So now let's figure this up. We have 100 grams of magnesium sulfate. The molecular weight says that 1 gram of magnesium sulfate is equal to 120.37. Oh my goodness. See? This is not rehearsed. I'm sorry. What the molecular weight tells us is it's 120.37 grams, of magnesium sulfate is equal to 1 mole of magnesium sulfate. That would tell us how many moles of magnesium sulfate we have. Now, we also know that 1 mole, by definition, is equal to 6.022 times 10 to the 23rd particles. Just like 1 dozen is equal to, remember 1 dozen is equal to 12. Well, 1 mole is equal to 6.022 times 10 to the 23rd. So now remember, we multiply by everything on the top, and we divide by everything on the bottom. So let's do that. We have 100 times 6.022 times 10 times 10 to the 23rd power. Divide that by 120.37. So I'm going to put my answer up above here in a different color. The answer that I get is 5.00 times 10 to the 23rd molecules or particles of magnesium sulfate. And if you want to double check, you can make sure that your units cancel out. We have grams on the bottom, moles, and moles. So the only thing left are particles of magnesium sulfate, or molecules of magnesium sulfate. So hopefully this has helped you in learning to go from grams to moles and moles to particles. We can do one more practice problem if you would like. This time I'm just going to figure out water. So, why don't we figure up, let's figure the mass of three moles, and the abbreviation for moles, by the way, is MOL, 3 moles of water. Okay, we have to know the molecular weight, or the formula weight, of water, and so that's 2 hydrogens, and each hydrogen is 1.01, plus 1 oxygen, which is 16, so that's going to give us 18.02 grams per mole. So if we start off with, I'm going to change my color for those who aren't colorblind, hopefully it'll help differentiate things. We have 3 moles of water, and we know that 1 mole of water is equal to 18.02 grams of water. Multiply by everything on the top, divide by everything on the bottom, which of course divided by 1 is the same number. And you get 54.5 0.06 grams. So that would be your final answer. I suggest that you practice doing many of the suggested problems to help you become more familiar with converting between grams to moles, moles to grams, and also from moles to number and a number to moles. I'll see you in class.